In this tutorial, we will explain what are strong acids and what are weak acids. So what's the difference between strong and weak acids? Here we have some examples of strong acids. Hydrochloric acid, HCl, nitric acid, HNO3, and sulfuric acid, H2SO4. All of these are examples of strong acids. Other acids are called weak acids, and examples of weak acids include ethanoic acid, which is found in vinegar. Its common name is acetic acid. Citric acid, which is found in citrus fruits. And carbonic acid, which is found in rainwater or in fizzy drinks. These are examples of weak acids which aren't harmful even in concentrated solutions. So ethanoic acid and citric acid are used in our food, and thus they are not harmful. Let's take two acids. The first one is hydrochloric acid and the second one is ethanoic acid. This is a strong acid and this is a weak acid. Both solutions have the same concentration, which is 0.1 mole per cubic decimeter. So these are two acids which have the same concentration. If we measure the pH of these two solutions, we will find that hydrochloric acid, which is a strong acid, has a pH of 1.0, whereas the pH of ethanoic acid, which is the weak acid, is only 2.9. So even though these two acids have the same concentration, they don't have the same pH. And from the values of the pH, we can conclude that the solution of ethanoic acid isn't as acidic as HCl. We know that as the pH increases, the acidity decreases. So because ethanoic acid has a higher pH, it's less acidic than HCl. The question is why? So these two solutions have the same concentration. Why don't they have the same pH? For acids to show their acidic properties, they must dissolve in water. So acids will dissociate in water. They will split up. Actually, all acids, when dissolved in water, will produce H+ ions. So the molecules of the acids will split up to form H+ ions and negative ions. Let's start with HCl. HCl, hydrochloric acid, is a strong acid. HCl molecules will all ionize in water to produce H+ ions and Cl- ions. And this is a complete reaction, so strong acids will ionize completely in solution. However, if we examine the reaction of dissociation of ethanoic acid, we will find that ethanoic acid will produce ethanoate ions, CH3COO- ions, and H+ ions. However, this isn't a complete reaction. So a position of equilibrium is reached when both molecules, ethanoic acid and ethanoate ions, are present. However, the majority of the molecules will be ethanoic acid, whereas the minority will be ethanoate ions. So only a relatively small proportion of the weak acid, ethanoic acid, will ionize in the solution. So most of the species present in the solution will be ethanoic acid, and just some of the ions will be ethanoate ions and hydrogen ions, H+ ions. So if we compare between HCl and ethanoic acid in a solution, we will find that all HCl will dissociate to produce H+ ions, whereas some of the ethanoic acid will produce H+ ions. And thus, even though we have the same concentration of both acids, we don't have the same concentration of H+ ions. And the pH depends on the concentration of H+ ions. So the more H+ ions we have in a solution, the more acidic the solution will be, and thus the less pH value we will have. So this explains why two solutions of the same concentration of HCl and ethanoic acid have different pH values.